There are a lot of version control systems around today. Why is it that given this large choice, some of us still find it worthwhile to work on CAMP and darcs? There are a number of reasons that we prefer CAMP and darcs to the competition, but in this video I'm going to explain what I think is the most fundamental underlying reason, which all the other differences fall out of, and that's how the version control system views the repository. To demonstrate the difference, I'm going to create a small repository with two version control systems at once, with CAMP to demonstrate how CAMP and darcs view the repository, and with Git to demonstrate how other version control systems view it. So to start with, let's create an empty directory and initialize it with both CAMP and Git. Git is going to keep its metainfo in the .git directory, while CAMP keeps its metainfo in the _camp directory. They'll both share the same working directory. Now let's create a file in the working directory containing 5 lines of text. We add the file to both version control systems and tell them both to record it as a patch called base. Now we change the second line of the file and records the change as a patch in both version control systems. Then we do the same with the fourth line of the file. Then the second line again. And then the fourth line again. Finally, we rewrite the entire file and record that as a patch in both version control systems. Now let's look at what Git thinks the repository looks like. Git, like most version control systems, is concerned with what the actual history of the repository was, what actually happened. So in its view of our repository, we recorded the patch base, then we recorded the patch that changed line 2 of the file to get us to this state, then to this state, then to this state, and so on. Now let's look at the repository as CAMP sees it. CAMP isn't concerned about what actually happened, but about what changes we made. So the repository starts off with the base patch, and then the next patch changes the second line of the file. The third patch changes the fourth line of the file, but we could do these changes in either order, so neither patch depends on the other. Changing the second line of the file again depends on this previous patch, and likewise changing the fourth line of the file again depends on this patch. Finally, the patch that rewrites the entire file depends on both patches. So why is this important? Well, let's suppose that these changes to line 4 are bug fixes, while these to line 2 are experimental new features. We need the bug fixes, but we don't want the experimental new features. So let's make a new repository and do an interactive pull from the main repo. We need the base patch, but we say no to the experimental new feature patch. Then yes to the first bug fix patch. Note that the second experimental feature patch has been skipped, as it depends on the first one that we've already said no to. Then we say yes to the second bug fix, and the rewrite patch again is skipped as it depends on the experimental features patches. If we look at the file, we can see that only the line 4 changes have been applied. And if we look at the repository, we can see that we only have the line 4 patches. If we later decide that we want these new features, then we can pull them in. And now you can see that the line 2 changes have also been made to the repository. The graphical view of the repository now shows that we've got a branch in our patch dependencies. Finally, we can pull in the rewrite patch, and we now have the rewritten file contents. The repository view now shows the same set of patches as in the original repository, but they have been reordered within the constraints imposed by their dependencies. Of course, it doesn't always work out how you'd like. Sometimes you want to pull a patch, but not pull one of its dependencies, and then you have to fall back to creating a new patch like you would have to do in one of the other version control systems. But a lot of the time, you are able to pull just the patches that you want without any problems. For example, in the GHC project, we have 2 branches at any one time. One branch is the stable branch from which minor releases are made, and the other branch is the head branch from which the next major release will be made. All of the bug fixes, features, refactorings, etc. are done in the head branch, and then the bug fixes that need to go into the next stable release are pulled into the stable branch. Most of the time, a simple darcs pull of the particular patch name is able to take care of this by itself. And so that's why we think it is worth continuing to work on camp and darcs despite the plethora of alternative version control systems out there.